Let's learn about Heckman's selection model from econometrics. So the goal is to correct for selection bias. And then let's jump to an example. Let's say we're interested in wage and their relationship with, let's say, education, age, and gender. But we only know wages if they're employed. So there is selection bias, because the fact that they have a wage means they are employed. Only know wages for employed. So Heckman's selection model is 2 steps. So step 1 is known as the selection equation, where we model the selection bias. So in this case, we model the fact that they're employed, and we'll model this on our covariates up there, which is education, age, let's say this is gender, etc. And then we want to take the probability of being employed and use that later. And what we're going to end up using is something called the inverse Mills ratio. I'll leave that as extra material for later. The idea of inverse Mills ratio is you're using the probability of being employed as a covariate itself. So this is the formal calculation. We won't go for the details. The basic idea is, hey, let's use the fact that they're employed later on to account for that selection bias. So step 2 is known as the outcome equation. And this is where we go back to modeling wage, which is equal to our education, age, gender, plus ... And then the key part is we're using this inverse Mills ratio, the idea or the fact that they're employed. So we're trying to look for age and its relationship with education, age, and gender, controlling for the fact that we're selecting on employed folks.